Well, in this video, I'm gonna talk about characteristic function for normal vector. Consider X an n by n vector has normal distribution with eta as mean and C is covariance matrix. It's actually n by n matrix. We can define characteristic function as expectation of exponential of j omega 1 x1 plus omega 2 x2 and finally plus omega n xn. We need to compute this expectation to find characteristic function for normal vector. If we want to compute this directly, we need to compute a multiple integral of probability, joint probability density function. Actually, it's like a multi-variable, multi-dimensional Fourier transform of probability density function. But it's not easy to find this integral, and I'm gonna use another technique to compute this. Consider a normal variable. W is a scalar, is a random variable. Distribute with a mean of eta, so W and sigma to W. We can find the Fourier transform of the probability density function in one dimension. It's easily to find it, and I can write the characteristic function for W like this. I will explain this in future videos. If you have problem for finding the characteristic function in one dimension, let me know in comments. And so I need to find, actually, if consider this, we can consider this combination as W. When we have joint normal variables, you know that the combination of these variables is also normal. You know, this is the definition of normal vectors and normal variables which are jointly normal. So this combination is a normal variable, and I consider this as W. Now we have expectation of exponential of JW, and this is actually the characteristic function of W when we put omega equals to 1. You know that? It's 1 point of characteristic function of W, you know? The characteristic function of W is like this, and when we put omega equals to 1, we have this. So I can use the characteristic function of W and put omega equals to 1 to this. So I just need to find eta W and sigma to W. If I find this, the proof and our computation is the linear combination of normal variables. I can write this in vector form. Actually, it's omega transpose X, where omega is a vector with elements and omega 1, omega 2 until omega n. And now eta W is the mean of W, and I can take expectation from the omega transpose X. It is omega transpose expectation of X, and it's omega transpose eta, where eta is the mean of the X. And sigma 2, it's expectation of W minus eta W power of 2. I can write this. Eta is omega transpose X, and eta W is omega transpose eta. Because W is a scalar, I can take transpose, so I can write W, but in this time I take transpose. So we have X transpose omega minus eta transpose omega. And it's omega transpose exponential of X minus eta multiplied by X minus eta transpose, and this is a covariance matrix of X, so it is omega transpose C omega. Okay, I find eta W and I found sigma 2 W. Now I can put in the previous formula and find W must be 1 here, omega must be 1. Exponential of j omega transpose eta, exponential of minus 1 over 2 omega transpose C omega. And we find the characteristic function of a random normal vector. Thank you for watching this video. I hope you enjoy it.